Hello and good day in pre-algebra. We are correcting PO15 before having a little 5-point quiz on it, 5-question quiz on it, just to kind of get this idea really cemented in our minds, because you'll be using it very frequently, these concepts, as we get deeper into pre-algebra. So this first row here is all about combining like terms, okay? 3n plus 9n is the same as having how many n's? 12 n's, okay? Those coefficients, the 9 and the 3, just get added together. The n doesn't change because it represents, what the object is. We have 3 of them. We get 9 more. Total, we have 12. All right? Second one, 14n minus 20n. Who wants to share their answer for that one? 14n minus 20n. Yvonne? Negative 6n. 14 minus 20 is negative 6. Good. 5 plus 8n plus 18. Who wants to share their answer for that one? Connor?
31.
Sorry?
31.
31n. Well, here's the problem with that, and I assume you got 31 by adding 5, 8, and 18, right? The 8 is the only term with an n. The 5 and the 18, we would call them constants. They don't have any n's. We're not getting any more n's from the 5 and the 18. We only have those 8. The 5 and the 18 do get combined to get 23, but that's got to stay a constant. So really focus on what are my like terms, okay? If you can combine them, they'll either have the same variable or they'll both be constants, right? So 8n plus 23 should be your final answer. We have those 8 n's we can see there, and then a constant of 23. Negative 6 minus 3n minus 7 plus n. Let's start by identifying the like terms here. What are the terms that we can combine? What are the terms that we can combine? Good. Negative, I'm glad you said that. Negative 3n, that sign belongs to it, and n, right? What's the coefficient to that variable n? Even though it's not written, Aiden? 1. It's a 1. So negative 3 plus 1, right? We're starting with negative 3 n's. We're adding 1. That gives us negative 2 n's, okay? Then we look for our constants. Negative 6 and negative 7. What do a negative 6 and negative 7 give us? I seem to remember doing this one together. Didn't we do it? I think we did. What's negative 6 minus 7? If we did do it together, just look at your page. Negative 6 minus 7. Negative 13. And so that would be the answer. Okay? We would not go further and take negative 2 minus 13 to get negative 15, because we don't have negative 15 n's. We have negative 2 of them, and then a constant of negative 13. What's that? Question? Okay. Second row is all about distribution. Okay, we've got those parentheses, and our goal here is to get rid of them. And the process that we learned about is the distributive property, which means we distribute or we multiply what's on the outside of the parentheses by everything on the inside. So 5 times n is 5n. 5 times 3 is 15. Biggest mistakes folks make, and check your page for this, is they'll add 5 and 3 to get 8. Right? We are multiplying here. 5 times positive 3 is a positive 15. So 5n plus 15. Can't go any further. 5n, 15, not like terms. Okay? So you have to keep them separate. The next one. Watch signs on this one here. Negative 3 times a positive 2 is a negative 6n. Negative 3 times a negative 9 is a positive 27. So negative 6n plus 27. And the reason why it's positive 7 plus 27 is we have a negative 3 times a negative 9. Those signs belong to them. And a negative times a negative is a positive. Okay. Sometimes I'll get the question like, well, you told us you can't combine 8n and 23 because they're not like terms. So how can we multiply 5 times n there? That 5 doesn't have an n. How are we able to combine them? Negative 3 times 2n, that negative 3 doesn't have an n. Why can we combine them? Okay, and the answer is the rules for those like terms exist only with addition and subtraction, not when you're multiplying or dividing. Okay, if you think about fractions, when do you need those common denominators, those like denominators? When you add and subtract, right? Do you need them for multiplying or dividing? No. Okay, so there are certain things in math, we've talked about this before, where the rules for addition and subtraction are sometimes more difficult than multiplying and dividing. With fractions, adding and subtracting, like denominators, like terms matter. With multiplying, they don't. And we see the same thing here. Okay. So the third one, positive 10 times negative 5n, negative 50n. Positive 10 times negative 8 is a negative 80. And so we write minus 80. Okay. Negative 50n minus 80. And the last one, I do remember talking about this one. That negative sign out in front is really just a negative 1. So when you distribute that negative 1 in, all that really happens is the signs of the terms within your parentheses change. The numbers don't, because they're just multiplying by 1, but because it's negative 1, positive 4n becomes negative 4n, negative 12 becomes positive 12. Okay. Questions on the distributive property? Okay. Walking around, I did see a few errors on these bottom 4 here where we kind of combine both concepts together. So if you are getting these wrong, make sure you're making your corrections, asking your questions, so we can figure out what's going on here. Okay. And I'll start by saying that remember what separate terms. Okay, addition and subtraction separates terms. So in this first one, where we've got 4 times n plus 3 plus 8n, this plus 8n is not part of our parentheses at all. Okay, we're not multiplying by it. It's not included in it. It's completely separate. So when we distribute, which we do whenever we have parentheses, and we get 4 times n, which is 4n, and 4 times 3, which is positive 12, that 8n just drops down. Okay? It's not part of that distributive property. Now, though, where do we go from here? Anna. Right. Now it looks a lot like what we had in the top row. Right? With those parentheses gone, now we look for what terms can we combine. We have 4 n's. We get 8 n's more. Total, that's 12. And so we have 12n plus 12. Okay? Second one, similar thing. It's very tempting to want to add that 9 and 3 to get 12 and then distribute that 12 into parentheses. That's mathematically illegal, right? Because that 9 is separate from our parentheses. What are we multiplying our parentheses by? Just the 3. So the 3 is what gets put in. The 9 drops down just like the 8n did. And now we've got 3 times n, which is 3n, and 3 times negative 5, which is negative 15. So if it's not part of your parentheses, it's not a coefficient, it's not included, just wait on it. Distribute first, and then combine like terms. So positive 9 and negative 15. 9 minus 15 is a negative 6. So we got 3n minus 6. 3n minus 6. We can't go any further because that n term and the negative 6 not like terms. So we keep them separate. Next one, kind of like the first one, only our n term is out in front this time, not behind the parentheses. Doesn't change anything. It's not part of what's happening here. We're distributing in that positive 7. So the 12n comes down. 7 times 2 is 14n. And 7 times 8 is negative 56. 7 times negative 8, negative 56. We can combine like terms with the 12n and the 14n. Total, that's 26. 26n minus 56. Okay. And last but not least, kind of like the second one here, don't subtract 20 and 5 to get 15. That breaks the order of operations. That 20 is just going to come down, and the negative 5 gets distributed into parentheses. Negative 5 times positive 2 is a negative 10n. Negative 5 times negative 4 is positive 20. We look for like terms. We can combine. Turns out we've got two positive 20s here, which give us a positive 40. Negative 10n plus 40 would be our answer. Okay, so like I said, we're going to have actually 6-question quiz right now. 2 of them will be from the top row type situation, 2 of them from the second row type situation, and then 2 of them from the combination at the bottom. Right? Any questions on PO15? Okay, we're going to pause the video to take this brief quiz, and we'll continue after. Nope. All right, I turn back on the recording. Just those at home can see the 6 that we are practicing with here. So go ahead and pause the video and jot these down. I'll go over answers shortly.